Hi folks, we're going to take a look at a couple of examples of derivatives with logarithmic functions. So here we'll start with page 309, 3f. So we're given this function, which includes the natural logarithm. Now we know the derivative of ln x is 1 over x. So here we do not have that there, so we're going to have to use the chain rule. So here we'll use the variables that are given. So here it's w is our function, and our independent variable is z, so we'll say dw dz. Okay, and so as we usually do, we'll make this whole thing ru. Okay, so first we're taking the derivative of ln u with respect to u, which is 1 over u, or 1 over square root of z squared plus 3z. Okay, and then times the derivative of u with respect to, in this case here, z. Okay, so that's a slightly more complicated function, so we'll have to again use the chain rule. So this is like z squared plus 3z to the 1/2, so the derivative will be 1/2 z squared plus 3z to the negative 1/2. Okay, and then we'll have to take the derivative of z squared plus 3z. Okay, so times 2z plus 3. Okay, so let's go ahead and simplify this so we get some practice doing that. So let's see what we have left in the numerator. So it looks like the only thing that's left in the numerator is the 2z plus 3. Okay, and in the denominator we have the square root of z squared plus 3z. Okay, we have our 2, and here we have another square root of z squared plus 3z. Okay, so it looks as though we can do some more simplifying because these multiply nicely. So in the end, we're left with, in the numerator, 2z plus 3. And then in the denominator, we've got 2 times this multiplication, which is just z squared plus 3z. Okay, so that's that one there, about as simple as we can get it. Okay, let's move on to this next one here for I. Okay, so we're given this function again with a natural logarithm, but we're going to have to use a chain rule again. So if we want to find f prime at x, okay, we're going to make this whole thing ru. So first we take the derivative of ln u with respect to u. That's 1 over u, or 1 over x squared plus 1 over x minus 1. Okay, and then times the derivative of u with respect to x. So here we're going to have to use the quotient rule. So derivative of the numerator is 2x times the denominator function, x minus 1, then minus the numerator, x squared plus 1, times the derivative of the denominator, which is just 1, okay, and all over x minus 1 squared. Okay, now let's go ahead and simplify this here, because I think a lot of nice stuff will go on. So here 1 over this fraction is just the reciprocal. So here we've got x minus 1 over x squared plus 1. And then here we've got 2x squared minus x squared. So we're just left with x squared. And then here we've got a minus 2x. Okay, and then here we've got, looks like a minus 1. All over x minus 1 squared. Okay, so here this x minus 1 will cancel out with one of those x minus 1s. Okay, and it looks like we can go further because this is not factorable. Okay, so actually we can't go further. So it looks as though this is as far as we can go. So we've got x squared minus 2x minus 1 all over x minus 1 times x squared plus 1. Okay, and there's our derivative. Again, just using all the same methods and tricks as we had in the past, just with these new logarithmic functions. So I'll just pan out here so that you can see the full solutions. Okay, that's it.